Hello, everybody. We're going to start looking at some real world problems and trying to use our multiplication and division skills to solve these. So this is something you've seen before when you're dealing with decimal problems. So I'm going to bring it back up again because it's going to be the same kind of thinking that we're trying to use. Back in the day when you learned multiplication, you probably learned something like if you're doing 3 times 5, thinking about, well, you have 3 5 times, or you have 3 groups of 5 or 5 groups of 3. Okay. So in that thinking, when we're thinking about word problems, you want to see the relationship between the numbers that it gives us. So, and that's going to look a little differently depending on what the problem is. But it might be something like number of hours times how much you make per hour gives you the total that you made, right? So the number of hours, that's kind of like the number of groups. Okay, how much you make for each hour is kind of like the size or the total of each group. And you multiply those to get the total. It might be something like the number of hours you're traveling times how far you go each hour gives you the total distance you've traveled. Okay, so there's groups, a number of groups, and how big the group is. Those are the two parts that multiply to the whole. Okay. On the other hand, if you have a division problem, you'd be given the total and one of the parts that you're dividing to find the other part. So if I use those same examples, you might be given the total that you made and how many hours it took. You divide those, figure out how much you made each hour. You might be given the total distance you traveled divided by how long you were traveling, and you're dividing to find how much you traveled each hour. Okay, something like that. So we want to be using that same kind of thinking to try to figure out, do we have the total in one of the parts, or are we to have the parts that would multiply to the total? So for each one of these examples, I'm going to give you a chance to try to decide what you think, if this is multiplication or division, and then we'll do it. Okay, so this one, a training session lasting 9 hours. Here's a number we're given. Has scheduled breaks every 2 1/4 hours. And I'm looking for how many breaks. Okay, so you want to think which of these two would multiply to the other one. Okay, so we have the number of hours. Okay, how big each section is basically, and how many breaks or how many sections there will be. Okay, so pause the video, decide if this is multiplication or division, and then move on. Okay, welcome back. This one is division. Okay, hopefully you recognize that this 9 hours is the total time. Okay, this tells us we have scheduled breaks every 2 1/4 hours. That means this tells us how long each section of training is. How many breaks will tell us how many sections of trainings there are. Okay, and then you multiply those together, how many sections there are times how long each is, to tell you the total time for the session, which is 9 hours. So we're given the total, which is 9. We have to divide by 2 1/4, which is how long each session is. Okay, so I can write 9 as 9 over 1. 2 1/4, I got to change that to a mixed number, or an improper fraction. So 2 times 4 is 8, plus 1 is 9, that is 9/4. Okay. All right, now because this is division, we're going to do keep, change, flip. So we keep 9 over 1, change it to multiplication, and flip. 9/4 becomes 4/9. Okay, so I'm ready to multiply this out. Remember, I can multiply it and then reduce, but it's better if I can reduce first. And I see I got a 9 on top and a 9 on bottom. That's really nice. Anytime you have the same thing, you can divide the top and bottom by. We can simplify that way. So those will both be divided by 9. So 9 divided by 9 is 1. And those will cancel each other out. Okay. Now when I multiply, I see I have all 1s on the bottom. So I'm going to end up with a whole number, because 1 times 1 is 1. On top, I have 1 times 4 is 4. 4 over 1, or 4 wholes, is just 4. So that tells me how many sections are going to be. Now I want to be a little careful because that's not exactly what's asking. It's asking how many breaks there will be. All right, so if I think about, this is being the whole session, this is 9 hours. Okay, I know if each section is 2 1/4 hours, that'll take 4 of them to do the whole training. Right, so that's what I just found out. This goes into 9 4 times. Okay, so if this is the start of the training, this is the end of the training, and there are 4 sections. Well, there's 4 sections. How many breaks am I actually going to have? I'm going to have 3. I'm going to have 1 break between the first and the section, another break at the midpoint, and then a 3rd break between the 3rd and the 4th. Okay, so this 4 was necessary in figuring out kind of what the day looked like. But you want to be real careful, make sure you're answering the question. If it asks how many breaks, there's going to be 3 breaks. There's my answer. Okay. All right, let's try another one. Mandy is building shelves along a wall that is 9 1/3 feet in length. If each shelf measures 2 1/3 feet, how many shelves will she build? Okay, so I'm going to have you pause it again, try to decide if this is multiplication or division. Are we given 2 parts that would multiply to a total, or are we given a total in one of the parts? All right, welcome back. So the numbers we have are 9 1/3, 2 1/3. Okay, I want to know how many shelves. Okay, so this is the length of the wall. This is how long each shelf is, and this is the number of shelves. So hopefully we can see that the length of each shelf times how many shelves will give you the total length, which is going to be the length of that wall. So we're given again the total and one of the parts, which means this is division. If I take the total, 9 1/3, divide it by 2 1/3. Okay, so how many times this can go into this is how many shelves I can build in this distance. Okay, if I'm going to divide these, first thing I got to do is change them to improper fractions. So 9 1/3, I had to do 9 times 3 is 27, plus 1 is 28, so I got 28 thirds, divided by 2 times 3 is 6, plus 1 is 7, 7 thirds. Okay, so I'm going to make this a mix. I'm going to turn this into a multiplication problem. I'm going to do my keep, change, flip. So I keep 28 thirds, change it to multiplication, and flip. 7 over 3 becomes 3 over 7. Remember, we always are flipping the second number. All right, now before I multiply this out, I see a 3 on top and bottom. Those can cancel each other out, just dividing those by 3. Okay, also, if you know your times tables, hopefully you recognize 28 is one of your 7s. It's a multiple of 7. All right, 28 is 7 times 4. So I can divide this and this by 7. Okay, so 28 divided by 7 is 4. 7 divided by 7 is 1. All right, so when I multiply these on top, these are just 1s now. 4 times 1 is 4. 1 times 1 is 1. 4 over 1 is just 4. Okay, and in this case, that is my answer, because this is the number of shelves I can build, which is what it's asking. Okay, so 2 1/3 goes into this 4 times. I can do 4 shelves that are each this long, and this would be the total length. And if I want to check that, I could. If you multiplied 4 times 2 1/3, you would get this. All right, let's do another one. All right, a log cake measured 12 1/2 inches in length. So there's a number. The cake was cut in 25 pieces. Okay, find the length of each piece is what I want to find. All right, so am I given 2 parts and asked for the total? Or is it saying I'm trying to find one of the parts and one of these numbers is the total? Okay. All right, pause and decide, then we can resume. All right, welcome back. This is a division problem. Okay, so the length of each piece is one of the parts. The other part is how many pieces there are. Okay, the number of pieces times how big each piece is gives you the total length, which is this 12 and 1/2. Now, it might be tempting to say that 25 is the total because it's the biggest number, but we're working with fractions now, so the total is not always going to be the biggest number. If we're multiplying by something less than 1, our number gets smaller, not bigger. Okay, so be careful. This is the total length of the cake. Okay, so I take the total length, which is 12 and 1/2, divide it evenly into 25 pieces. So I'm dividing by 25. And that'll give me how long each piece is. Okay, so 12 and 1/2, if I make that a mixed number, that's 25 halves. Divided by 25, I can write as 25 over 1. And again, I'm going to turn that into a mixed number. So keep, change, flip. Gives me this. Keep 25 halves the same. Change the multiplication. Flip. 25 over 1 becomes 1 over 25. Now that's really nice because now I got a 25 on top and bottom, and those can cancel out. So I'm dividing both those by 25. And once I do that, I just got 1 times 1 on top, 2 times 1 on bottom. I get 1/2. So the length of each piece, this is measured in inches, is 1/2 inch. Okay, so 25 1/2 inch pieces, you do this length total. We can hopefully see now why this number is bigger than this number. Right? Each piece is less than an inch, so 25 pieces is going to be less than 25 inches. All right, let's look at another one. Jogging track around the lake is 2 2/5 miles long. There's the length of the track. Jog the track 2.5 times is how many times we jog it. Okay, how many miles will you have jogged? Last thing we don't know. Okay, so is this thing we're looking for the total, or is that we get from multiplying these, or is it one of the pieces and one of these is the total? Pause and decide. All right, welcome back. In this case, this one that we're looking for is the total. All right, the relationship here is how long the track is times how many times you run it will give you the total that you jog. Okay, so this is a multiplication problem. 2 2/5 times 2 1/2. Okay, so I don't need to do a keep, change, flip here. I do still need to turn them into improper fractions. So let's do that. 2 times 5 is 10, plus 2 is 12, 12/5, times 2 times 1 is 4, plus 1 is 5, so I have 5 halves. Okay, before I multiply, I'll look for things I can cancel. I got a 5 on top and bottom. That's nice. I can divide those by 5. And then 2 and 12, I know are both even numbers, so I can divide by 2. 2 divided by 2 is 1. 12 divided by 2 is 6. All right, now multiplying out, I got 6 times 1 is 6. 1 times 1 is 1. 6 over 1 is just 6. We've seen this a couple times. You might be noticing if you have just ones left over on the bottom, your answer is going to be a whole number, right? Because 1 times 1 is 1. Anything divided by 1 stays itself. So I end up with 6. This is asking the distance in miles. So I would say 6 miles. Okay, you go 6 miles total if you run this track 2.5 times. All right. Let's look at another one. 5/8 of the 120 zoo employees. How many workers is that? Okay, so what this is asking is what is 5/8 of 120? 120 is people. How many zoo employees there are? 5/8 is the portion that are working. Now, I told you before, this word of, when we're dealing with multiplication, or when dealing with fractions, of is a keyword that means multiplication. So anytime you want to find a fraction of a number, you just multiply the number by that fraction. Here's an example. Okay, so I want to find what 5/8 of these 120 zoo employees are. So I can take 120, I'll make it a fraction, multiply it by 5/8. Okay. If I wanted to know 4/5 of this number, I'd multiply it by 4/5. But it has to be 5/8 of the numbers. That's what I'm multiplying by. All right, so I look. You may not be able to tell immediately what the biggest number is that goes into 8 and 120. That's okay. We can actually divide them by 8, so you could go right there. But if you can't quite tell that, we can see that they're both even. 128 are both even, so I know I can divide by 2, so I'll start there. So 8 divided by 2 is 4. 120 divided by 2 is 60. Now if you look at these numbers, 60 and 4, they're both still even, so I can divide by 2 again. That becomes 2. That becomes 30. And again, they're still even, so I can go one more time. So 2 divided by 2 is 1. 30 divided by 2 is 15. So it might take you multiple steps. If you can't see the biggest number you can divide out. That's fine. Just like with reducing fractions, you just need to make sure you go until you can't go anymore. I have ones left on the bottom, so I know I can't. There's nothing else I can divide out. Yeah, that also tells me my answer is going to be a whole number. Right? So do 15 times 5 is 75 over 1, which is 75. That's asking how many workers, so that's the number of workers. So 75 workers will be at the zoo. Okay. Now, if I check to see if that's reasonable, 5/8 is a little more than half. Right, half of this 120 would be 60, and I have more than that. So it seems like a reasonable answer to me. All right, let's do a couple more. So Rhonda is 5 1/3 feet tall. Her youngest brother Andy is half her height. What is Andy's height? So again, for Andy's height, we want to know half of Rhonda's height. So I want to know what half of 5 1/3 is. So again, to find half of a number, I can multiply it by 1/2. You could also think of as dividing it by 2, but when we do keep, change, flip, dividing by 2 is the same thing as multiplying by 1/2. This is what it would turn into. So I can go ahead and make these mixed numbers. 5 times 3 is 15, plus 1 is 16 thirds times 1/2. Okay. Looking for things I can reduce. I see 2 and 16 are both even. I can divide by 2. Okay, that's all I can do. So I got 8 times 1 over 3 times 1, 8 thirds. Okay, I want to simplify it, which means making it a mixed number. 3 goes into 8 2 times, with 2 left over. So 2 and 2 thirds. This is measured in feet. That is how tall her brother is. And that seems half of 5. That seems about right for half of 5. All right. For this last one, this one gets, let's do this one. This one gets a little weird. This one, we got to be careful what we're asking again. So we're putting up a fence that's 26 feet long. So let's pretend this is my whole fence. We're going to put steel posts every 6.5 feet. Okay. So 6.5 feet is how big each section is between posts. We're also putting a post at the beginning and end. I don't know how many steel posts will be used. Okay. So again, on this one, we're given the total length of the fence, which is 26, and we're given how big each section is. So this is another division problem. We're doing 26 divided by 6.5. So how many sections this size can fit into this? Okay, so I'll make both of these fractions, 26 over 1, divided by, make this improper, 6 times 2 is 12, plus 1 is 13, 13 halves. All right, so I've got a division problem. I'm going to do keep, change, flip to make this multiplication. 26 over 1 times, I flip that to be 2 over 13, which is again nice because you might notice 26 is just 13 times 2. So I can divide those by 13, 1 and 2. Okay, on top I have 2 times 2 is 4, 1 times 1 is 1. That gives me 4 over 1 or 4. So that tells me that I can fit 4 of these 6.5 foot sections. That's not really to scale, but let's pretend. Okay, because 6.5 goes into this number 4 times. Now, again, the question I'm trying to answer, I gotta be careful, is how many steel posts? Doesn't ask how many sections will there be, it's how many steel posts. I'm putting one between each section and one at the beginning and end. Okay, so if that's the case, I got 1, 2, 3, 4, 5. 3 are between the sections and then 2 on the ends. So I would need 5 posts to do this. Again, be really careful. Make sure it's always a good idea after you finish the math to go back and make sure you're answering the question that's being asked. All right, so that's all I got for you. I'll give you a chance to give it a try. Good luck.